Hello, my name is Dr. Lauf, and today I'm going to be guiding you through the VyOS Network Configuration Lab. This lab is important because it teaches you many basic and fundamental concepts in setting up a router and understanding how subnetworking works between two networks. Furthermore, it's going to teach you some basic concepts of firewalling and how to prevent unnecessary access from outside your network perimeter. All right, so welcome to the environment that we have. We have two Kali Linux boxes. One is our external box and one is our internal box. And then we have a router. This is running VyOS. So before we get started, we're going to simplify a few things. My external box, I'm going to change the color scheme of the desktop so that I always know what kind of machine I'm working on. So let's see if we can pick this black background, and then the blue one is fine for the internal. So the black machine is always going to be the external box, and the blue one is going to be the internal, just to use some of the preloaded desktop backgrounds. And here we have our VyOS server, which is our router. Now, a router is an often misconstrued device. All it is a machine that allows you to move packets between two networks. That's all a router is. And what we're going to do is show you the very basic configuration of this router. When you go buy a router at Best Buy or some electronic big box retailer, you'll typically get an all-in-one device that includes a router, which is equipped with a firewall and some sort of other set of software suites that go with it. They're equipped with switches, so you have Ethernet support, and they're also equipped with a wireless access point. Those are three devices in one. And all three of those are typically running together, and they're all in one box, which is convenient, but they're neither powerful nor effective, in my opinion. I actually prefer to split those out into the respective components so you get a better experience overall. But we're going to go ahead and set this router up, and if I type show configuration, if I could type, and if you don't want to type all this stuff out, you can actually use tab complete. So if you hit tab, you'll see that there's a few options. If I hit show conf and hit tab, it'll autocomplete this for me. And this, without knowing what this is a blank VyOS configuration. There's nothing there that is going to be set up. And it looks like there's stuff there, but really kind of there isn't. And we can kind of confirm this if we do a show interfaces. We see that there's an Ethernet 0 and Ethernet 1, and they're down. There's nothing there. They're essentially not configured, and then we have a loopback interface, which we're not going to worry about. Anyway, we're going to go ahead and check to see if we have internet access on this machine. So we're going to go ahead and pull up our terminal, and we're going to ping google.com just for fun, and we can see, in fact, that the pings are returning. By the way, to stop this in Linux, you're just going to hit Control-C on your keyboard, and it'll stop. And we see that we have 0 packet loss. Everything was transmitted. Now, we're going to try to do the same on our internal machine, and something's going to happen. It's just going to say, I don't even know what this is. In fact, there's nothing configured on this network interface. We see a little icon here. It says no network connection. That's kind of what we expect. So the external Kali box is sitting kind of outside the network. The internal Kali box is eventually going to be configured to be running privately on the internal network. So our first step that we're going to do is we're going to enter the step configure. And this brings us to a new prompt. If you see the hash sign or the pound sign, that means you're basically the super user, and you're going to be working to configure. And all we have to do is add lines that basically tell VyOS or Viata, which is the underlying component, or VyOS, how to set up a service called IP tables, among other services that come included with VyOS. And we're going to use some simple entries to do this. So we're going to go ahead and define our network interfaces. The external interface, which is the one that talks to the outside world, if you will, that is going to get configured with something called Dynamic Host Configuration Protocol, or DHCP, and that's going to get its own IP address externally. The internal side is what we're going to have to configure manually. So we're going to start with both. Let's start with the outside interface. So we're going to do set interfaces, and you can tab complete here. What kind of Ethernet, what kind of interface are we working with? We're working with Ethernet. And what interface name? Eth0 or ETH0, however you want to pronounce it. And let's set its address. So we're going to use the address keyword, and we're going to use DHCP, Dynamic Host Configuration Protocol. Bam. Now, if we hit show, we'll see that there is a series of plus signs here, and these are the entries that we have just added. Anything with a minus is a deletion, anything with a plus is an addition, and everything else is as before. Okay, let's go ahead and go to our second command. We're going to do set interfaces Ethernet ETH0. Now, one thing we can do is we can hit the up key, and it recalls our previous line. This is universal in Linux command line. Works in Windows. And we're going to change its description. This is just for our use, and we're going to call it description outside. Note that you cannot tab complete a description because the computer has no idea what you're trying to do with it. All right. Now, next command is set interfaces. And by the way, you can tab complete at any time to see what the options are. Now that we've set the outside, actually, let's just do a show here. And you can see our configuration file. And I'm sorry, the machine is being a little bit slow here. And we can see that we have defined an Ethernet interface for the outside. It's just called outside, and it gets its IP via DHCP. And that's what we expect it to be. Now let's set the inside. So we're going to do a set interfaces and Ethernet again. And this time we're going to do Ethernet 1. And we're going to give it an address because we have to do this part manually. There's no way to get an address from a system that you're defining. And we're going to create one, 10.0.1.1. That is going to be the router's internal interface's IP address. And we're going to put a /24, which means that this is a network that contains 8 bits that are used to set the IDs of the computer behind the network. So we can have a total of 254 machines on this subnetwork. And cap that off, and there it is. Lastly, we're going to use the up command, and we're going to change the description. Let's see, we don't need to change the address because we've already done that. So description, we're going to call it inside. All right, so now if I do a show, and by the way, you don't have to show the whole configuration file. We can do show interfaces. And if we do that, there are the things we just added. We have an Ethernet adapter, Ethernet 0, and an Ethernet adapter, Ethernet 1. This one is getting its IP address from the outside, and this one is manually being set, and that's why we have 10.0.1.1/24. That's insider notation. Now, in the instructions, there's something about setting the service port. We don't need to do that for the case of this lab since we have command access, but you can do that. It's the set service SSH port 22. That just means that we can theoretically connect to the router from another machine, but we're just going to use this, this terminal here, so that's not an issue for now. The next thing we have to do is set what's called network address translation. Network address translation is the process by which an internal network is represented to the outside network. Now the router does something unique. It does a process called masquerading. And masquerading basically tells any computer on the outside, hey, I am all of the IP addresses on the inside. And it keeps track of whatever computer on the inside makes a request to any machine out on the open internet. And it represents that machine on the connections back and forth. The reason why we do this is because the router has one single interface on the outside, and that represents all of the IP addresses of the machines on the inside. That's called masquerading. So we're going to define our network address translation model and set up masquerading. So we're going to do that with set NAT, and we're going to set up a source rule, and we're going to give it a number, and the rules are followed in order. And we're going to set our outbound interface, which is the Ethernet 0 device, as Ethernet 0. We're just going to say, hey, the outside of this network address translation process should be bound to Ethernet 0. Okay, done. We're going to set NAT source. Oops, it would help if I typed. And we're going to, this response curve is really bad right now. Okay, 100, and we're going to pick our source address. And this tells the network address translator what addresses should it mimic or accept. 10.0.1.0/24. Note that when we were setting the internal interface for the router, we were using 10.0.1.1. 10.0.1.0 says for all addresses on 10.0.1. whatever represent this. Okay, so we're going to go ahead and save that, and we're going to set NAT source rule 100 to translation method. And the translation address translation method that it's going to use is called masquerade. And that is what I had just mentioned to you earlier. Okay, now if I do a show NAT, assuming it's going to respond to me sometime today, there are all the NAT rules that I just created. There's rule 100. It says what our outbound interface is, and we're using from source addresses 10.0.1. everything behind that, and then we're using masquerading as our network address translation method. So I'm happy with this, and I'm going to go ahead and commit. And what this does is it checks to see if there are any errors, and if so, it turns on those rules. Now you're going to see starting DHCP client on Ethernet 0. That's expected. If you see cannot get current device settings on duplex, don't worry about that. That's just, it's not an error. It's just expected because of the VM configuration that we have for the Ethernet network interfaces themselves. I'm happy with that. It worked, so I'm going to hit save, or going to type save and exit. Okay, now it's important at this point that we need to discover what our interfaces look like. So we're going to do a show interfaces. Look at this. We have now on Ethernet 0, which is our outside network Ethernet device, it has magically been assigned an Ethernet an IP address of 10.0.0.206, and it's been done. It's been given that by a router that is actually upstream that's been configured for you. And Ethernet 1 is 10.0.1.1. That's our private internal network. And there is a DHCP service that we're going to set up later that's automatically going to hand out IP addresses there. But for now, we're going to manually configure it. Okay? So, important to know these addresses. We're going to reference these later. So right now, we now have a routable system. It needs to be manually configured on each machine behind the firewall, but nonetheless, it is routable, it's usable, we can actually function with it. And we're going to configure this Kali Linux box to work with it. Okay, so to do that, I'm going to do it manually. I'm going to do a sudo, which stands for superuser do. That is a simple command that's used to elevate privilege. I'm going to type in nano, which is an editor that I'm going to use, and I'm going to edit a file called network interfaces in the etc. Folder. And now it's going to make me type in our password, which is defined in your lab documentation. And we're going to edit after this auto loopback interface setup here. And if you look at your lab notes, it's going to say iFace, which stands for interface, Ethernet 0. Now this is Kali Linux's machine's Ethernet adapter. It's separate from anything that's connected on the VyOS box. They're connected to the same subnetwork physically, but Ethernet 0 is just the name of the network card on this Kali Linux box. And we're going to set it to a static IP address, and that's important later on. Now we're going to set the address to 10.0.1.10. We're going to set what's called a net mask or a subnet mask, which tells the network card what kind of addresses it should be able to reference on the subnetwork. We're going to give it a broadcast domain of, this is actually not strictly a necessary entry, but we're going to put it anyway, 255.255.255. That basically says it's able to join the broadcast domain of a very large group of network addresses. And lastly, we need to tell it how do you get to the next set of networks? How do you get to the open internet? How do you do any of that? And we do that with a gateway. Note that a gateway is not necessarily a connection to the internet. In this case, it happens to be it, and that's our VyOS router here. So what gateway should we use? The internal network address of the VyOS router, because this machine is connected internally and this machine is connected, has an internal network interface. So we're going to use 10.0.1.1, and that's telling the Kali box, hey, go ahead and try to talk to the router that we just set up here. Okay. Now we're going to hit Control O and S, or Control O and Enter, and that saves it, and then Control X to leave. Now, if we do an IP address command, or ifconfig, for those of you familiar with that, you're going to see that this is still not set up. So we're going to need to manually configure that, and we're going to do a sudo if up and Ethernet 0. If up stands for interface up, and once I do that, looks like I have an error here, so let's just edit that real quick, see what a mistake I might have made, and then see what's going on. Oops, yeah, I forgot a big keyword. I forgot to put inet on here. So that is in your documentation. See, everybody makes mistakes. Now we'll go ahead and bring the interface up again, and this time it should work. And there it is. And it's not going to work perfectly with all of our services yet, but the important thing is I should now be able to ping, which is a command that allows us to talk to, or to basically check if a connection is up, the router. So let's try that. Ping 1.1. That is the internal address here. We want to see if it responds. I'm going to go ahead and do that. And as soon as the machine responds, hey, look, there's traffic actually coming back from our router. And I'm going to go ahead and cancel that. And we have 100% packets received, packets transmitted. Okay, now that's important because it shows that we are able to talk directly to the internal side of the router. That's expected. Now let's see if we can talk to something on the outside. Okay, now we're going to go ahead and see if we can, first of all, reach the same router that this external Kali box is connected to, and that is actually 10.0.0.1. That's what this Kali external is talking to. That's its gateway. So let's go ahead and see if we can talk to that. And in fact, it's returning our pings. That's great news. Now let's see if we can talk to the actual Kali external itself, which is at ping 10.0.0.199. And what our expected behavior is, it should respond to our pings. And in fact, that's exactly what it's doing. So we're actually able to talk from Kali internal through the router to Kali external. Okay? And that's important because it shows us that we're able to correctly set up network address translation and routing. So we're going to go ahead and stop the pings, and that was successful. All right. The next step that we're going to do is we're going to change our configuration to dynamic host configuration. And to do that, we're going to go back to configure. That brings us to our configuration shell, and we're going to configure a service. So we're going to do set service, and the one we're calling is DHCP server. And a DHCP server, dynamic host configuration protocol server, kind of works like this. When a computer joins a network for the first time or after being powered on again, it'll say, hey, can I get an IP address here? And the DHCP server will respond and say, hey, give me your MAC address, and I'll go ahead and assign you an IP address. And that's what we're setting up for the private network that Kali internal is connected to. We're going to set up this DHCP server. And we're going to use the shared network name attribute, and we're going to call it LAN. And then we're going to say that we're going to use 10.0.1.0/24, which is the internal IP range that Kali internal is connected to and will be connecting to. So we're going to pass it that. And we're going to tell it that the default router, I think I have an error. Yep, after shared network name LAN, I need the word subnet. So my apologies. That tells us that we're using subnet 10.0.1.0/24, and we're using the default router attribute. So all computers will be told that are connecting like this that 10.0.1.1 is the default router. So in other words, it's setting the gateway attribute. Okay, so it should like that. Next, we're going to use the up key to pull up the previous line. We're going to go back, and we're going to tell all computers what domain name server are you going to use, and we're going to use the router itself. So DNS server is going to be 10.0.1.1. We're telling all the computers, hey, if you need domain name services, go ahead and talk directly to this router, and this router is going to do something called forwarding. That's what we're going to set up next. All right, so this is set the DNS server entry. You can set up backups as well, but for now, we're not going to do that. We're going to skip the domain name. Well, let's go ahead and put it just for fun. Domain-name, and we're going to just call it VyOS.net. It doesn't matter what this is. It's not going to affect us. We're going to set what the lease time is. The lease time says, hey, when you secure one of these dynamic host configuration provided IP addresses, how long is it valid for? And we're going to set it for 1 day, so 86,400 seconds. 24 hours is typical. On very dynamic networks, you may want it a lot shorter than that, and you can do it as long as a few days if you want. Note that most of these machines, most of these routers, will actually keep track of the IP addresses that they hand out, and if they see the same MAC address on the computer, this has nothing to do with Windows versus Apple. This has to do with media access code address on the network card. If it sees that same MAC address, it'll assign it the same IP, unless a lot of churn has happened, a lot of different machines come and gone, and it ran out of IP addresses, and so it couldn't keep those reservations. So that's great, and our last thing that we're going to do is tell it the range of IP addresses that it's supposed to take. So we're going to do a set service, we're going to do DHCP server, and we're going to do shared network name, and it's called LAN, and subnet 10.0.1.0/24. And we're telling it that the start of the IP address ranges is going to be 10.0.1.5, sorry, and stop is at 10.0.1.250. So this tells us that the starting address that it's going to hand out are 10.0.1.5, and the last address it'll hand out is 10.0.1.250. What happens if you exceed 250? Well, you're out of IP addresses, and you might need to pick a different subnet size, such as a 23 or 22. Okay, that'll add, instead of 256 computers, it'll bring you up to 512 or 1,024 machines on the network. Okay, so we're going to go ahead and tell it to do that. If we do a show service, you will see all the entries that we just made. These are the entries for the DHCP service. Now we need to add one more, and that's the domain name service. This is what allows you to figure out that if you go to google.com that there's a certain IP address associated with that. For instance, if on my Kali external I do a ping google.com, it'll tell me that the IP address for the Google server that I'm connecting to is at 142.250.191.110. Google.com is a lot easier to remember than that particular address, and the domain name service allows you to alias servers so that you can connect to many different servers even with the same domain name. There's a whole lot of things that DNS does, but it's kind of out of the scope of this refresher here. So we're going to set up the DNS forwarding service. So set service. We're going to use DNS, and we're going to use forwarding, and we're going to specify cache size. This is how many entries it's going to save. We're going to save 128 entries. We're going to listen for DNS questions from Kali internal and all other machines that would be internal to that network on Ethernet 1. That's our internal interface. And we're going to set DNS forwarding to a particular name server that we're going to send it to, and that's 8.8.8.8, which is Google DNS. Or you could use OpenDNS. You could use AT&T or Time Warner or whatever's DNS that you, or Spectrum or Comcast, whoever you want, you can use their DNS servers. I'm just using 8.8.8.8 as an example. Okay, now if I show service again, I can see I've added a DHCP server service and a DNS server, forwarding server service. That looks good to me, so I'm going to commit. Hopefully it'll buy my changes, and it just did, and I'm going to hit save and exit. At this point, we're halfway done with VyOS. If I do a show configuration, oops, you'll see all these services are now added. All these Ethernet interfaces have been configured. All this is ready to go. So now this Kali internal will work as designed. However, I'd like it to be getting its DHCP provided IP address. So I'm going to do a sudo nano, and by the way, you see how it's giving you a predictive entry. If you hit the right arrow key, it'll type all that in for you, and hit enter. And then in nano, we're going to go ahead and delete all of the entries for the DHCP configuration. And then we're going to exit and hit save. By the way, Control O is to save. And just for brevity, we're just gonna reboot the machine. And while we reboot, I'm going to explain what's going to happen next. So there's a common misconception that a network address translation method, which I've told you provides you with a private IP address, a private network of IP addresses on the inside, and one public IP address on the outside. There's a misconception that this provides some form of security. And we're going to see that that's absolutely not the case. So now that we've rebooted, by the way, we can see that our configuration is connected. And in fact, if I go ahead and do an IP address, before I even show you, what IP address do you expect the Kali internal box to have now? Here's a hint. Remember the range of IP addresses that we specified in the service configuration for the DHCP server. That answer should be 10.0.1.5. Look, there it is. That was the first IP address in the range. If I added another Kali internal, a separate box, connected to the same router on the inside, it would get 10.0.1.6, and so on and so forth until we hit 250 and ran out of IP addresses. Okay? So we can connect 245 machines roughly. Okay? Now I'm just going to see if our network works. So I'm going to ping google.com. This shows us if the DNS forwarder is working. And look, there it is. I can ping google.com. I can even do one better. If I load a web browser, we should be able to connect to some form of a web page. And if I just go to google.com, it should load up just fine. Look, there it is. How about that? So we're able to access the internet through our router. Now, remember our IP address is 10.0.1.5, and our task now is to see if we can ping this internal machine from the external. So let's try that just for didactic reasons. We're going to try that, ping 10.0.1.5. Now, before I hit enter, what do you think is going to happen? Is it going to succeed or is it going to fail? Take one more mental note and let's see what happens. All right, I've hit enter and it's failing. Now, why did it fail? I want you to think about that for a minute. And if this is all new to you, don't worry if it doesn't quite make sense. I'm going to explain it all for you. So all this has failed. And the reason why it has failed is if I do an IP address, you'll see that the network on the Kali external is a 10.0.0. It doesn't know what a 10.0.1 something is. And remember, Kali internals are on 10.0.1 something. There is something that we can do, however, and that we're gonna create a static route that tells the external Kali how to connect to the internal machine. And how do we do that? Well, we got to go back to VyOS, and I'm gonna bring up a screen that's gonna make this a little bit more clear. We're gonna show interfaces, and we see that our external IP address is 10.0.0.206. What's familiar between 10.0.0.206 and 10.0.0.199? It's both /24. That's right. These two, this external Ethernet interface and Kali external, are on the same subnet. Now, it wouldn't matter necessarily if it were. This could be some sort of publicly routable external IP address like you would have on your home internet connection at the outside edge of the router. But the important bit is that I can use this outside IP address to my advantage. And what I'm going to do is I'm going to do a route add. So I'm going to do a sudo route add, and the network address range that I would like to go to is 10.0.1.0/24. That is the range of network IP addresses that I would like to add a route for, because right now the machine doesn't know how to do it. The next statement is going to be GW for gateway. Now this is a question, this is an IP address that most people get wrong, and it's for good reason people get it wrong, because I'm making you think backwards. When we were configuring Kali internal, I made you use the router's internal IP address as the gateway to get to the rest of the world. Now we got to do the reverse. I'm telling a computer that's outside in the real world, or a simulated real world essentially, how do you get to another machine or another subnetwork? And we're actually going to use the outside interface, Ethernet 0. This is the outside interface from the router to talk to essentially tell Kali external how to get to one of these networks, one of these IP addresses in the private network that Kali normally has. And we're exploiting network address translation to do that. So we're going to feed in 10.0.0.206. 10.0.0.206. And when I do this, this will create the route that Kali can use. I'm going to hit enter. And I have to feed in my, my password. And now the route has been added. So watch what happens when I go ahead and try to ping 10.0.1.5. Do you think it's going to work? Yeah, look at that. I can literally communicate to an internal computer through the router's network address translation masquerading system. That's because the router is telling outside machines, hey, I am all these IP addresses, and if you need to get to one through 10.0.0.206, I'll take care of that for you. It basically masquerades as the entire private network. And doing so, it happily allows you to penetrate the network. So what's missing in all this? Well, that's the last exercise. So now for the last piece. How do I prevent this external Kali box, which could be an attacker, from going through the network address translation mechanism and talking to an internal machine? By the way, the implications of this are that if I knew your router's external IP address, which has to be public, or at least has to be accessible through a series of routers, I could theoretically exploit network address translation and talk directly to one of your computers on your network, whether that's your smartphone, your desktop, laptop, whatever, or smart home devices. I could do that. Now, that's why all the routers that you buy, at a big box retailer, or that you could theoretically configure for yourself, that's why you set up a firewall. And note that a firewall is basically level 0 of defense. Defense in depth, meaning that we have many different layers. The firewall sits at your perimeter. Once a firewall is breached, the firewall is breached. There's nothing you can do about it. But let's go ahead and talk about the firewall rules that we're going to create, and then we're going to see if we can still ping from outside to inside. All right, so I'm going to go ahead and go back to configure. And we're going to set firewall. Firewall is a core service. It is not configured in this default empty configuration, so we're now going to add it. So we're now going to create two rule sets, or sorry, two firewalls. One's called outside in, and the other one's called outside local. So we're going to set up a name, outside in, And we're going to say, by default, drop everything. Any packet coming in, drop it. Now that's actually going to create problems for us. So we're going to create rules in order that get around our problems. But the default action is drop. So anything that is unsolicited, anything at all, the last action in this firewall chain is drop. So far, so good. Now we're going to set a rule, because we can't just drop all traffic. That would be problematic. We're going to use a rule, and 10 just means 10, 20, 30, 40, or you could do 1, 2, 3, 4, 5, doesn't matter. It follows the rules in order when it tries to see what to do with a packet. So rule 10, our action for rule 10 is going to be accept. Now what are we accepting? Well, that's the next bit. We're going to accept connections that have been established. And we're going to use the established state, and it's going to say establish enable. And what is this going to do? Well, when I make a request from an internal network through the firewall to a remote server, that remote server has to be able to talk back to me. Otherwise, you could never see web pages, or literally you couldn't do anything on the internet if your firewall just dropped all returning packets. So when the internal box makes a request to the outside internet or to another machine through the firewall, it creates what's called an established connection. And that established connection is what we're going to configure and allow in the firewall. So that's why we have rule 10 state established enable. We're going to set up one more here, set state related enable. This is not strictly necessary, but it'll help us for other issues. Now we're going to set up another set of rules. Outside local. This is, again, we're going to set a different set of rules here. Our default action is going to be drop. And we're going to, again, do a rule set for outside local. These are just two different firewalls that we're setting up. Rule 10, action, accept. I think we could just do with the outside in firewall or versus the outside local, but that's okay. We can set up different rules for different reasons. And then we're going to go through the same stuff before. State established enable. Enable. And state related enable. Now, if you're doing a true enterprise network setup, you're going to have a lot of these firewalls set up with a whole bunch of rules, because sometimes you need to allow unsolicited traffic in as long as you know what you're doing with it, and that's okay. Now, we're going to go ahead and apply. Let's see, what are we going to do? We're going to apply them to the correct Ethernet interfaces. Set interfaces, Ethernet, ETH0, firewall, in name, and we're going to use outside in. That's for the incoming. Now we're going to set the Ethernet 0 firewall policy for local traffic. Set interfaces, Ethernet, ETH0, local, oops, I need to put firewall, local name, and we're going to use the outside local rule set that we just made. Oops. Something broke in my command line. Let's just fix this. Local name is outside local. And when I bind this, it now has bound the firewall policy. So if I do a show, I should now see, oops, I skipped it. So show firewall. Here are my firewall instances. And if I do a full configuration show, it should eventually map the firewall to the respective Ethernet interfaces. Now that's actually been by doing the statement that we just did, the set interfaces Ethernet Ethernet 0, that's actually going to activate those interfaces for those firewall policies. So we're going to go ahead and hit commit. And if everything worked right, it should be happy with this. And I'm going to save it. All right, now the moment of truth. First of all, let's see that I didn't break everything. I'm going to go ahead and try to ping google.com. And in theory, there it is. So everything's coming back as expected. So I know that established connections are working. Now comes the real moment of truth. Can I still get to the internal Kali interface from outside? Remember, the route is still saved. By the way, if you reboot your Kali external, the route is deleted. So you may need to re-add it if you reboot it for any reason. Let's try it. And no pings coming back. The firewall is effective. So network address translation, a lot of people used to think that that actually protects your network connection, your internal private machines. It certainly does not do that. A firewall is your basic level 0 protection against unsolicited traffic coming into your private network. Does that all make sense? And that, now we can go ahead and exit. And that, ladies and gentlemen, is how we complete the VyOS Refresher Lab. I hope you enjoyed this Networks Refresher Lab. If you have any questions, please reach out to me or contact one of the program coordinators.